Welcome to another video for Variety and Fun Math and Martin Tutorials. Variety and Fun Math is math that should interest most people and other interesting stories, and Martin Tutorials is only mathematics. Both YouTubes are free to subscribe. You're all encouraged to. And what's beautiful, not only is it free to subscribe, you get a full refund if you're not happy. How's that for a great deal? Anyway, today we're learning more about the Pythagorean theorem and its uses. The theorem, we believe, was discovered or at least cultivated by Pythagoras, who lived many years ago. And many of you have, I'm sure, have heard of this theorem before. The theorem states that if you have a triangle with a right angle that's 90 degrees, like usually where a wall meets the ceiling, one shorter side squared plus the other shorter side squared will equal the longer side squared. That's any right angle triangle. There's another one. That means if this is drawn perfectly, like a computerized perfect, we measure this perfectly accurately and square it, measure that perfectly accurately and square it. Those two totals together will equal the longest side, also called the hypotenuse squared. So this theory would not be true for this triangle because I do not believe I see a right angle. Now, given that a number squared, that's also the area of a square. Like if a square is 5 by 5, the area will be 5 times 5. If we extend the square from each side of a right triangle, the two smaller square areas will equal the longest sides squared. So if I write it as c squared equals a squared plus b squared, where c squared is the longest side of a right triangle, I can also write it as c equals the root of a squared plus b squared. There's an equal sign. What I do to the left, I do to the right. So the square root of c squared is c, so I put a root sign over that. Okay, so how can we put that to use? Well, here's one example. Let's say we've got a room or a hall, and I did not draw the entire room, but we have to paint a line across the diagonal of this room. We know that one wall is 5 meters, the other is 12 meters. And for some reason, it's difficult to measure this diagonal. Maybe it's we don't have the correct measuring tools, but we already know that's 12 and that's 5. We can use Pythagoras. 5 squared plus 12 squared equals h squared. I just called it h for hypotenuse. I could have picked any letter I wanted to. So h is the root of 5 squared plus 12 squared. Simplifying 25 plus 144 adds up to 169. It equals the root of 169, which is 13 meters. In this case, that diagonal is 13 meters long. Here's another example. We have a building that's 20 meters high. We at a point 10 meters along the ground, and we know that the building is perfectly vertical and the ground is completely horizontal. We want to attach a wire from the top of the building to this point 10 meters away. And of course, one problem, we can't exactly walk up in air with a measuring tape and measure. So what can we do? Here's another example where Pythagoras gets put to use. As we know, in this case, this is a 90-degree triangle. If we're not 100% sure it's 90 degrees, Pythagoras will not work. Based on what we've learned, w squared equals 20 squared plus 10 squared equals 100 plus 200. W squared equals 300. Therefore, w is the root of 300. And using a calculator, corrected 2 decimal points, it's 17.32 meters. There's another example of how we use Pythagoras to solve a problem. Our problem is we are unable to measure that distance, like with a measuring tape. It's too long for most measuring tapes, and you cannot walk up in the air. We use Pythagoras, and that's what mathematics is. It's a tool to solve problems. Hope you all have a great day, and I hope you enjoyed this quick lesson about Pythagoras and some of its uses.